Alright, so we're going to be doing a lot of the homework together. So if you go ahead and open up the homework, we'll do the ones that are similar for everybody. So here's a little flow chart that we just did. Most of the homework is just saying which method you would use to solve it, but not actually solving them. There are a few that you are going to solve, but for the most part, it's just saying which one you would use. Alright, so everybody's question 1 through 7 is the same, 1 through 6 is the same. So those are the ones we're going to look at together. And then we'll go jump to the ones you actually have to do work. And then the rest of the time is you just working on it. Alright, so here, if we look at the first one, again, the first thing we always want to check for is a GCF. So is there a number we can divide both of these by, or a variable? So since they're both end in a 5 and a 0, that means they both can be at least reduced by 5, maybe more, but for sure 5. And they also have an x, and not just an x, but an x squared. Okay, so we're not actually going to do it. We're just going to say that it's possible to be done, and we'll say GCF is the method that I used. So that's all we're doing for this first part. You're just saying which of these 6 methods you would use to solve it. Alright, so that's it for the first one. Moving on to the second one, number 2. So here this time, checking for a GCF again. We see if there's a number I can divide both of these by. 4 is 2 and 2, 25 is 5 and 5, so no number. So then I go to see what kind of polynomial it is. Since there are 1, 2 terms, I'm in the binomial situation. So it's going to be one of these, either difference of squares, sum of cubes, or difference of cubes. So it's not going to be basic, it's not going to be grouping, it's not going to be AC, it's not going to be GCF because there's no GCF. So it's either cubes or squares. And it's difference because it's a minus sign. So we know it can't be sum of cubes because it's a subtraction in the middle. So it's either difference of squares or difference of cubes. We got to look at the numbers and the exponents. So here, 4 and 25. 4 and 25 are squares, and it's a squared. So this tells us it's going to be difference of squares and not cubes. So here we would just choose difference of squares as the answer for that one. All right, so again, that's what most of this homework is just going through and saying which method to use. We are going to review how to do each one, but it's important that you know which one to use, otherwise you're not going to know what to do. Okay, so again, same thing. You still go through GCF. Is there a number we can divide both of these by? No, because that's 2 and 4, and 5, 5, and 5, so no number. So then I look at the terms. There are 1, 2 terms. So again, I'm in this situation. So it can't be trinomial, it can't be AC or grouping. There's no GCF, there's no basic. So it's either difference of squares or difference of cubes. Because it's a subtraction sign, I know it's difference. So it can't be the sum one. Then I got to see, is it squareds or cubes? So really, the exponent gives it away usually. So since this is a cube exponent, I'm going to do cube difference. But then you also have to look at the numbers. So 8 and 125 are perfect cubes. So here, this would be a difference of cubes. All right, and then again, we would use the pattern to finish off factoring it, but we don't have to do that for this first one. All right, number 4. So now, again, this time, we always want to check if there's GCF. So is there a number we can divide everything by? No, because the first one doesn't even have a number. Is there an x we can divide everything by? Nope, because the last one doesn't have an x. So So no GCF. So then I look at the terms. There's 1, 2, 3 terms. So we are in the trinomial case. So again, it can only be either basic or AC, so not difference of squares. It can be AC, maybe basic, not cubes, not grouping. Right, and then to tell which one it is, you look at the number in front of the x squared. So if there's not a number in front of x squared, we use basic. If there is a number in front of x squared, we use AC. So over here, here's x squared. There's not a number in the front, so then that means we're going to use basic. And again, just reviewing what basic is, this is where you put the last number on the bottom and the middle number on the top. And then you just try to figure out your two numbers. But again, we're not doing it at this time. We're just saying which method to use. All right, and then number 5. So again, always check for that GCF first. So is there a GCF that we can divide everything by? 3, 2, and 5? Nope, those are all prime. So no GCF. There are 1, 2, 3 terms. So again, we're in the trinomial case. So our options are basic or AC. So basic is okay. Grouping is not okay. Sum is not okay. AC maybe. Difference of not okay. So it's either basic or AC. And then again, remember to tell the difference, I look in front of x squared. So if no number's in front of x squared, we use basic. If there is a number, we use AC. So x squared is here. It does have a number in the front, so that means we're going to use AC method and not basic. So again, the only difference between AC and basic, we're still going to use the x here, but instead of putting the -5 at the bottom, we have to multiply the a and the c together first and put -15 on the bottom, and then factor it and do all the other steps. But that's why it's called AC, is because the first thing you have to do is multiply the a and the c, and then put that number on the bottom, and then the -2 stays on top. Okay. And then the final one is where there's 4 terms. So again, you still check GCF. GCF. Can I divide everything by a number? Well, both of these can be divided by 8, but this one can't because there's not a number in the front. So no GCF, can't divide them by x. So now you count the terms. 1, 2, 3, 4. So right now, there's only one method that we can use to factor 4. We don't know division yet, so we're not going to even talk about that one. It has to be grouping. That's the only way we know how to factor these right now. So factor by grouping. And again, we're going to do this with another problem, but we would group the first 2 together, take out the GCF, group the second 2 together, take out the GCF. But if it's 4, it's easy because you know it has to be grouping for sure, because that's the only way we know how to factor with 4. When we add division tomorrow, well then we got to decide. But right now that's the only possibility. All right, so then 7, 8, and 9, they're kind of mixed up for everybody. They're all binomials. So you have to decide which thing to use. Is it going to be, so binomial, it can only be difference of squares, sum of squares, difference of cubes, or GCF. GCF is always part of it. So for 7, 8, and 9, decide which one of those it's going to be. They're not the same. So each of these is a different thing, so you have to make sure you choose the right one. And then starting with number 10, it's just asking you which can be factored with a particular method. So again, it might not be this exact problem, but this one's difference of squares, and then it asks for AC, and then it asks for GCF and difference of squares. So again, here you just have to decide if it can work or not. So the other ones that we're going to do together are starting with number 16 and going all the way to number 22. I think it's 22. No, 23 we'll do together. They're not going to be in the exact order, but you're going to have that problem somewhere on your page. So you're just going to have to look for it. All right, so starting with number 16, go find this one. It's going to be between 16 and 22. So go find this problem real quick.